Welcome back, guys. Today we are back with another problem, and today's problem is longest common substring. So longest common substring is an extended version of the problem of longest common subsequence. So earlier we have studied what is the longest common subsequence, but now today our task is to find out the longest common substring. Okay, so this is our goal. We have to find out the longest common substring. Okay, so how we are going to do it? We'll be having an input string. They will be having two input strings, string 1 and string 2. If you see the string 1 and string 2, the longest common substring or the particular word which is a part of a larger word has the maximum length. So if you see A B, okay, A no, doesn't matter. C matches, D matches, G matches, H matches, and again there is an R which does not match. So there are four letters. There are four letters, and that's why the output of this particular substring is 4. And we have to do this in O, N, and M time complexity. So what will be the efficient way to solve this particular problem? So if we do this in a brute force or a recursive manner, this would take longer time. So we will be solving this problem with the help of dynamic problem. So we will be solving using dynamic programming, okay, or DP. So how we are going to do this? So basically, first what our task is to, we will be having a DP table, okay, and we will be having our DP table. So, and what are the letters? Okay, there are, for total length we have to check the length, 3 4 5 6, 3 4 5 6, okay, and then we have to solve this. So say for example, this is our DP table, okay, and we will be having the numbers, we'll be having the indexes and then the letters as well. So first I'll be having the indexes, say I'll be having indexes 0 1 2 3 4 5 6, okay. Similarly I'll be having over here 0 1 2 3 4 5 6, okay. So in the DP table, I'm going to carefully fill the letters. Like if first rows and column will be zeros, okay. The first row and column will be 0. So I don't have to bother about that. I'll be just putting that, okay. And I will be showing you how efficiently the dynamic programming approach works and how we are going to code this in terms of code and all these things. So the first thing which we will be writing is from 1 we will be having, say, A B C D, and we'll be having another A C D G H R. So this is A C D G H R, and the first character which we have is A B C D G H. So we'll be having A B C D G, and we'll be having an H over here. Okay. So now we will be checking the similarities. So if it matches, then we'll be putting a 1 over here. Okay. So what we can see when it's 0 0. Okay. When I have 1 over here, 1 over here, yeah, that means it's matching, right? That means it's matching. So I'm going to put a 1 over here. I'm going to put a 1 over here. Okay. Now I'm going to check for 1 and 2, whether 1 and 2, whether A and C it matches. No, it doesn't match. So I'll put a 0. And then I'll put 0 for, because all these things does not match with A. So similarly, I'm going to put 0 0 and 0. Okay. Now let's come for the value B. So B matches with A. No, B doesn't match with A. B matches with C. B matches with C. No, B doesn't match with any of it. So I'm going to just put 0 0 0 0 and 0. Okay. Now let's come for C. C matches with A. Does C matches with A? No, C does not match with A. So what I can do is I can write a 0 over here. C matches with the C right now. Yeah. So I'm going to put a 1 over here. C matches with D, G, H, R. No, C does not matches. So 0 0 0 0. Okay. Now let's come to C, D, G, and H. D, G, and H. Okay. So when I'm talking about C, D, G, and H, first let us come with D. So D matches with A. No. D matches with C. No. But D matches with D now? Yes. But there is a previous match found. So the longest will be 1 plus 1. So now the value of D will be becoming 2. Now D matches with G. No, no, and no. Okay. Now let's come to G. G matches with A. No. G matches with C. No. G matches with D. No. G matches with G. Yes. So previous value was 2 plus 1. So this will become 3. And G matches with H. No. So this is becoming 0. Similarly, I'll be having 0 0 0, and do H matches with G? No. H matches with H? Yes. So there will be 3 plus 1, 4, and 0. So what I can see is now the values which I have is 1, 1, 2, 3, and 4. But I have to return the length of the longest subsequence, so I can find the maximum value, the max value, which is equals to 4. So 4 is the length of the longest common substring. So the longest common substring which we have, the longest common substring which we have is C, D, G, and H, which is 4. So with the help of dynamic programming, we can find out the length of the longest common substring, which is 4. So now what is the algorithm which we are going to write for this? So I'm going to quickly write the algorithm which we are going to write for this is if if our say first string dot character of I minus 1 is equals to str2 dot character of j minus 1, then the formula will be dp of I and j is equals to dp of I minus 1 j minus 1, okay, plus 1, and our max length will be equals to math.max of max length comma dp of I and j. So we can find out the max length, or else we can reset the characters. So we can write dp of I and j is equals to 0, which we have done over here. This means we have reset the characters, and whenever we are encountering a value, we are adding +1 to it. Okay, so this was the algorithm, and this will have a O of n cross n time rows and columns. So let us code this particular solution. So we'll be coding over here. So what we can see is we'll be having a longest common subsequence. But before that, I'm going to take the length. So int n equals to, I can say str1 dot len gth. Similarly, you can take the length of the second substring, you can call it m, and yeah, when the length of n and m is done, I can make a dp table equals to new int, say n plus 1, okay, and say m plus 1, okay. So once that is done, I can set my max length equals to 0, and I can fill the table. I can write fill the table. So we can fill the table using equals to 0, less than equals to n, plus plus, for int j equals to 1, j plus plus. Then I will be writing the condition, which is if a our character dot I minus 1, okay. So I can write if my str1 dot caret of I minus 1 is equals to 2 dot caret of j minus 1, okay. So then dp of I and j equals to 1 plus, I can write dp of I minus 1 j minus 1, okay, as simple as that. Then I can take my max length equals to math dot max of max length, and with that I can say dp, my dp table. So dp of I and j, okay. So I've taken my max length with this. Then we will have my else statement, which I said I'm going to resetting the values to 0 if not found, okay. And finally I'm going to return my max length. So let's compile and check whether this solution works. So okay, What I can check is where did I mess up? str1 dot length, str2 dot length. Okay, n and m. I guess n and m. Yeah, the longest common subsequence. So first, I have taken. Um, let me just check this. Change this to m and n, and yeah, m. Oops, it was all correct. So just now compile. So let me just check again. M plus 1, n plus 1, max length 0. Okay, so to start from 1. Okay, so now it's matching. I will submit the solution. So yeah, this was today's problem statement. And if DP always feels good, you get to learn a lot. And yeah, so make sure you like, share, and subscribe to this channel. And we are looking forward to solve more videos. Thank you so much.